Hey guys, Christian Ludemann here, and in this module we're going to learn about Backend for Frontend. So here's what we're going to cover. What is Backend for Frontend, or BFF? Why would you consider introducing BFF to your architecture? What technology should you choose for your BFF? And then we will look at how to create a BFF with tRPC. So let's dive right in. First of all, what is a BFF? So a BFF is a dedicated backend for the frontend. It's a service that is only getting called for the frontend and is intended to simplify the frontend, and is often used, for example, to aggregate data from different data sources or domain services. So it's having this abstraction or translation layer between the client and the deeper parts of the architecture, like databases or domain services. So its purpose is to absorb complexity from the frontend by returning exactly what the frontend needs and do all the work necessary to accomplish the use cases abstracted from the frontend. So for example, on startup, you might want to just only send one request to the BFF, and that's going to fetch the data it needs, maybe from different databases or different services, and then it's going to return exactly what the frontend needs from startup, for example, in one request. That is ideally how it should work, not multiple requests back and forth. And also from an architectural point of view, we don't want the frontend to know about the deeper parts of the architecture and the other deeper dependencies in the architecture. We want it to interact with a simple dedicated service, which is the BFF, and then that's gonna handle the communication with different domain services, so you don't get that all tied up in the client's front end. And that makes you're able to make changes to the client or the BFF without you can make changes to domain service, and it will only affect changes in the BFF. So you have so you kind of protect your client against changes. Otherwise, when anything changes, like from a domain service, you don't want that to result in a change in the client, so the BFF can handle that, as long as well as the performance benefits. So yeah, those are the benefits: simplicity of the front end. Front end will call a simple endpoint and get what it needs. So we will talk later like what that endpoint would look like, either like REST, GraphQL, or tRPC performance. When the BFF is co-located on the same network as the other data sources, like different domain services or databases, it can combine multiple requests faster as they are co-located on the same network. So that's going to be a lot faster rather than the front end doing multiple requests. So first of all, like JavaScript is serial, so you do one request at a time. Plus it would travel all the way from the client's browser to the data source, which will be slower than having it being fired from the BFF, which should be co-located on the same network to have the performance benefits. And then it acts as an abstraction layer. You can make changes to the domain services without needing to change the client. The BFF is handling that translation to the client. And also just front-end development becomes simpler, because you will interact with endpoints that will be exactly like as intuitive to the use case as possible, and just only providing the BFF what it needs and nothing more. And you will only get what you actually need. So all this other stuff you normally get from domain services, that's all abstracted away. You're only requesting what is needed, and you're only getting what is needed. So it's very simple for the front end. And also it can help during development if you need some data that's not already there, and it can abstract away that part and you can like create fake JSON data from endpoints that is not ready yet. And finally, if you have like a Docker setup, a virtual setup, you can use this for testing. You might have some end-to-end testing where you BFF for some endpoints you want to fake it. So that can also help, where you can spin up a test BFF that has some, maybe you have all the mutating requests, they're not actually mutating. Maybe you don't want that effect to take place, but it will still return some valid response that is similar to how it will be in production. So you can do things for test setup as well if you have a BFF, because you control all the external communication, the external gateway from the front end. So what about serverless? You see in smaller projects often like Firebase or Superbase, where you see these JavaScript clients, like Angular clients for interacting with the Firestore. And for simple projects, it can seem intuitive to work directly with the Firestore, for example. And it's less code in the end and less boilerplate to create another service and having everything run through the service. But as it scales, you're gonna have a tight coupling to Firestore, for example, in your Angular app. So that is maybe something you don't want, because that's going to make it very hard to then get rid of Firestore later. And it's, as we talked about in the clean architecture lesson, whenever you introduce some third-party dependency and you tie it directly to your front end, then you're gonna have some hard coupling to it. Yeah, you can abstract it away to some resource service and have it more manageable in that way, but you can also just move it all the way out of the front end and have the BFF handle all of the data access, which in bigger projects I believe is the right way to do it. But in smaller projects, maybe it's fine for you. Maybe it's not worth it to add that BFF later. So at least you would have the serverless access in some kind of resource service or some service where you keep all this abstracted away. So if you were to change the serverless technology to, let's say, for example, a real database, then you would only need to update in the resource services. So you keep that layered and that, abstracted away. But then later, if it scales up, then you might introduce the BFF and you might move all this up to the BFF. So move all the Firestore access to the BFF, and then the front end only knows about the BFF. So I believe, if it's a really simple project, yeah, you can do the serverless. But if it's, it's a more like a big corporate setup, you already need to aggregate requests to different domain services and data sources, then yeah, just go straight to the BFF. What technology for the backend for frontend or the BFF? So I believe that you should always go for full stack type safety in whatever you're doing. From the testing lesson, you get the cheapest coverage from type safety. So you should always max out your type safety. You should return only what's needed. So that's this classical problem with REST, where you would overfetch and you'll have to strip stuff away later. Or do a lot of processing on the front end to handle what's coming in. It's better to have the BFF just getting what you need exactly in the format you need. I believe it should be written in TypeScript, both the front end and the BFF. I believe they should be co-located in the same monorepo, so it's easy to make changes in both places. And the Angular developers should be able to work in the BFF, and BFF developers, which should be able to work with Angular. I believe it should be one of the same. Like, it is like a full stack job, but it's not too complicated and it's in the same monorepo, so everybody has access to the same code. I recommend you do it with tRPC, and that comes from having tried multiple different approaches, both the REST approaches. There's like Express, you can use Express, you can use Nest.js, which is something more like Angular, using a lot of decorators and stuff, more like opinionated REST framework. And then there's Apollo Server, GraphQL, which also has some drawbacks and is a big framework, has a lot of the caching engine is quite big, and I don't believe you should use the caching engine in your resource service. I believe that should be a separate concern, handling the state. So taking all these things into consideration, that's one way you can combine the best of GraphQL with having the schema, having one endpoint, and then having the schema, while allowing for batch requests. So you only send one request and you get all the data you need. So for example, you can have that, avoid multiple round trips on startup, while having that full stack type safety and having these DTO objects, which you will know from REST, in a rather automated way. And you get that from tRPC, and I'll show you an example how to work with tRPC. So that's what I have to say about that decision. I'll go with tRPC. Also, if you know from the Spartan stack, I made a video about that before. That also fits right in, and yeah, it is taking the best of both worlds, GraphQL and REST, while getting full stack type safety and getting this option to do the batch requests, which will give you the performance benefits while having this in TypeScript. And this is a good thing to have co-located on the same monorepo. So yeah, I'll go with tRPC. So let's look at how to create a BFF with tRPC, and I'll show you a simple example from our to-do app, how to set this up and how simple this can be set up. So first we'll set up the server. So this is residing inside of a domain library within the to-do library. So from the architecture, how I actually just show it here from the architecture here. So we have our libraries, and then we have our to-do app library and library concerning everything that works with to-do, which is both our to-do service and our to-do app. And then with this, we also have this tRPC server. So that's here, it's residing. And basically from here, we have, let me just go back to slides. We have initialization of the server, which is just calling this init tRPC. Pretty basic stuff. We create an in-memory to-do list. In a real setup, I will use a real database to get the data from, at least. Probably now I'll take something like Supabase and interact with that using some ORM here. Create the tRPC router, which is where we have the routes, the different I guess remote procedure calls, the different remote methods you can call from the front end eventually, and you can run them in batch. So if you have multiple of them, for example, fetching data, you can batch them together, and we'll look at that in the front end pretty soon. And then we can take the type of this router, and then we got some type safety we can use from the front end client to call these remote procedures. And this ensures that we have routes for the front end that is exposed as typing for the client. So then we get to the client. This is creating this tRPC proxy client right here. And we're using the types which is created from the server side. And we're using these links are you can chain these that handle the requests. So for example, you can do a logger that will log out in the console the requests that happen, as it can sometimes. So when this fires, like this is called terminating link, like a batch one, you can have multiple. You can do a promise resolve all and have multiple requests firing, and while having multiple of these, it will only resolve in one HTTP request that will trigger the remote procedure call. But the logger link can make it easier to log out what actually happened. So something you can add. I didn't do any transformers, but you can transform like using super.json to transform to the serialization of the data when you receive it. But yeah, that's basically it. And this is our endpoint we want to hit. And of course, you want this to be some dynamic URL, so it also works in production setups. And we can also see here how that would look when we fire this. So if we go to the domain here, we have the client. We can see, if I look at the usages, you can see where it's used, and it's used within this resource service. And it's just calling methods and then query, mutate, and then undo from to convert it to an observable. Otherwise it would be a promise. So yeah, pretty simple stuff. This is the mutations. So you see mutate and query, you see that are terms from GraphQL. So we kind of combine the best of GraphQL. We get the type safety. And in Apollo, you would need to have some code generator to have the TypeScript types generated. This is quite tedious, I think. Here you just get the type straight from the types of the routes. And then you just call the methods here. And it all takes care of that. So it's pretty simple. While you're getting the DTO, you get the types from like a to-do item from this. So that's why I like this. So we looked at what is a backend for frontend. Why should you consider that? The reasons are simplicity. In terms of like the architecture, have this abstract layer between the the frontend and the deeper parts of the architecture, like domain services and data access. And also like performance reasons. If BFF are located at the same network as the data sources, domain services, you can batch requests, and you can fire the request aggregating the different data sources faster due to the co-location and batching requests. And yeah, besides from that, it's just clean architecture practices. We are absorbing complexity from the front end, and the front end just has to worry about a simple interface that follows some use case names, and we can abstract all the data access out of the front end. And yeah, I would do it for everything that's not a complete simple project. And you can even just start just keeping like serverless, like Firestore, keeping that inside of the resource services. And then later you might move it to a BFF. So I'll always follow the clean architecture best practices. What's the technology for BFF? I think tRPC is the best option right now in terms of like type safety and having the best of GraphQL and REST. I tried a bunch of like REST and GraphQL solutions, and they all have like downsides. Use it with Apollo GraphQL, and setting up the typing is quite tedious with the TypeScript generation, and it's a big library, and I don't think you should use the built-in caching. I prefer to use my own caching solution for state management and keeping that as a separate concern rather than mixing it with my HTTP request library. And yeah, then we got the DTOs and all the type safety. So I think it's the best of both worlds, using tRPC as for your BFF. And we saw an example how to create a BFF for to-do app. There's some resources. You can see how I set up the BFF in the to-do monorepo. And you can see my Spartan stack YouTube video, where I also, on my YouTube channel, I also talked about how to set up this one, a whole Spartan stack, where tRPC is one of the elements of the Spartan stack, along with analog and Angular and different elements, which I believe is one of the best modern stacks that ideally give you like all the benefits you need in terms of like full type safety, server-side rendering, all this stuff. So yeah, you can check out this video and dive more into the different parts of the Spartan stack if you're interested in learning how to create a full Spartan stack. All right, I'll see you in Discord.